All right, this is the second part of the first unit for finance. This is the practice in algebra review. This is where you're solving for different variables and interest formulas. I skipped problem 2 because I feel like it was just kind of a repeat of some of the ideas from 1, 3, 4, and 5. So I'm just going to go ahead and work through 1, 3, 4, and 5 for that page. For the accounts problem and where you were like making the graph, that's kind of a review from modeling. If you need to take a look at that again in some of the particulars, I encourage you to do so, but I didn't feel like it was I don't want to make too many of these videos and inundate you so much with these notes. Okay, so if you need to focus in on this, then make sure that you're doing that. So let's do number 1 first. How much should you invest at 3% simple interest in order to earn 75% interest in 14 months? So our goal is to end up with $75 in our account. The account has a 3.7% simple interest. I want to know how much do I drop into the account first. So the formula that I'm going to end up needing to use here, and what gives that away is this little word right here, simple. Since I'm looking at simple interest, I'm going to need to use the simple interest formula, which I realize that doesn't look super readable. So that's P0 times R times cursive T for whatever reason. So this is going to be how we're going to compute our interest. We're using the interest formula because I want to earn $75 in interest. Okay, I don't want $75 in the account. I want $75 in interest. So I realized that I misspoke. Sorry. So our knowns, what's given to us is this R value of 0.037. And the reason we know this is because it's 3.7%. We're going to write that as a decimal because we're not a barbarian, and that's what we get there. And we know we need to earn $75 in interest, so our I is going to be 75. So the thing we don't know, something else we need to consider. 14 months simple interest is gathered annually. Okay, so what we need to do here is figure out how many years is 14 months. So 14 months divided by 12 months in a year, that's going to give us the number of years. So in the notes, we had talked about how you may need to do some dimensional analysis for your t value. This is a perfect example of that. So unknown, this is the bit we don't know. That's to be P0. We do not know this, okay? So we need to solve for that. So we plug everything in that we already know. We know that we're supposed to get $75 in interest. We don't know P0. We know that the R is 0.037, and we know that T is 14 over 12. Reducing the fraction is like a nice thing to do mathematically, but it's actually not doing you any favors at this juncture. So I personally would not do it, okay? So now we actually do the division. We divide both sides by whatever this number comes out to be. You're going to see that I kind of save computing what that actual number is until the very end. I think it's just easier that way. And so now I'm going to actually perform this computation. I'm going to use so many parentheses. So when I'm typing this into my calculator, that's a 1. I'm going to do parentheses around this guy, I'm going to do parentheses around this guy, and I'm going to do parentheses around this guy. So what I would end up typing in is 75. I really should do this in a different way. Divided by, and then all of these parentheses here. Okay, divided by all of that. And after I do that, what I end up with is, oh, look at that, I already typed it in. Oh, how fun, good, because that was looking dicey. So now I'm gonna type all of that in exactly how it's written, and I'm gonna end up with $1,737.45. What that means is, if I take $1,737.45 and plop it into an account with 3.7% simple interest, and I let it sit there for 14 months, I'm going to have earned $75 in interest. I have made $75, okay? Let's take a look at number 3. Graduation's 3 years away, and we want to have $1,200 available total for a trip. Okay, the trip is going to cost $1,200. If your bank is offering a 3-year CD paying 4.8%, simple interest. Read the problem. Simple interest. Okay. How much do you need to put in this CD to have the money for your trip? Okay. So the formula, since it says simple, we're going to use the simple interest formula. Now, we're not trying to compute 1,200 in interest. We want 1,200 available total. So we want this number here to be 1,200. Okay. So we're going to use the A formula instead of the interest formula because the interest formula, that's not, we don't know what we're starting with. So, and we're going to keep what we end up starting with. That's what we're going to end up withdrawing. So we're not just going to use I here. Known, I know that I need to end up with $1,200. I know that it's going to be for 3 years, and I know that the interest rate is 0.048. Again, it's going to be that 0.048 because I wrote my interest as a decimal because I'm not a barbarian. My unknown is P0. I don't know how much I'm going to put in to this account. I don't know. So let's go ahead and solve this using some basic algebra. This is not terribly crazy. What I've seen some students do is they'll distribute the P0 here and here. Don't do that. Don't do it. Don't do that. There's a time and a place for that, and that is not now. We're just going to go ahead and divide both sides by whatever this number comes out to be. We're going to go ahead and divide both sides by it. So you're going to notice I'm saving all of my numerical computations until the very end. What that's doing is that's preventing me from doing what's called intermediate rounding, where I'm doing rounding somewhere in the middle step of a problem. What that's going to do is that error that comes from rounding, and when I say error, I don't mean like wrong answer. I mean like the difference, the discrepancy between what my number comes out to be and what the actual number should be. That error is compounded. That error blows up. That error is being increased. Okay. So I don't do any intermediate rounding. I don't do it. I type everything in exactly how it looks. It's going to be really helpful to do it this way when you get into annuities and loans, because those formulas are kind of gnarly, and plugging stuff in is, it's more of a process, and rounding will be a killer for those. Okay, so really make sure that you're practicing not intermediate rounding. So now I end up with an initial value of $1,048.95. What this means contextually is that I'm going to put $1,048.98 into this account with 4.8% simple interest for 3 years, and I'll have exactly $1,200 available for my trip. Okay. So suppose I've got $1,800 in my savings account at the end of a certain time period. I invested $1,100 at 4.68, simple interest rate. How long in years was your money invested? Well, formula. Where did I get this formula from? I got it from simple. So simple. My known, I've got A is equal to the amount I should have after all is said and done, 1,800. I'm starting with 1,100. My interest rate is 0.0468. Write it all out. Don't just say that's about 5%. Don't do that. That's not, no. Those fractions of a percent, they add up big time, especially when we talk about annuities, we talk about mortgages, we talk about all that stuff. Folks fight and die for those extra 100th of a percent that you're just knocking off willy-nilly. Unknown, we do not know our t value, but we'd love to know it. That'd be great. So now I'm going to set up and solve this with basic algebra. Now's the time where you distribute that 1,100. So now I'm going to go ahead and distribute that 1,100 because this t is the thing that's unknown. Okay, this t is the thing that's unknown. Okay. For those of you who aren't familiar with what a cursive lowercase t looks like, there it is. So there you go. So now we distribute the 1,100. And now we're going to go ahead and just solve for t. So I'm going to subtract 1,100 from both sides. Okay, and then I want, this is after I multiplied these two guys together, 1,100 times 1,100 times 0.0468 That comes out to be 51.48. I want to get t by itself, so I'm going to go ahead and divide both sides by 51.48, and I get about 13.6 years. So it would take me 13.6 years to end up with that $1,800 in my account. Okay. All right, for number 5, how much would you need? And this is a really interesting question. How much would you need to deposit into an account now in order to have $2,000 in the account in 15 years? Assume that the account earns 7% interest compounded monthly. Uh-oh. Compounded. If you notice, it's not simple anymore. Okay, we're not using simple interest. We're using the compounding interest. Okay, we're using compounding. So this formula looks a little gnarlier, and it is a little bit, but you know, get okay with it. It's going to get worse before it gets better with these formulas. All right. Now, the known values. Here's what I know. I know that my PN is going to be 2,000. I know that my N value is going to be 15. I know that my R value is 0.07, and I know that K is equal to 12. Where did I get K is equal to 12 from, you ask? Well, monthly. That's how often our interest monster is visiting each year. Okay. So my unknown, I don't know P0. I don't know it. So I'm going to set up my equation here. Now, here's the thing. This whole big mamma jamma here is actually just a number, believe it or not. It's a number. It's a single number. So this really is P0 times whatever this number is. By the way, this is the number symbol, not hashtag, just for your own edification. But it's a number sign on its side. So there you go. We're going to divide both sides by that particular number, okay, by that number. And this is where we really need to pay mind to compounded error. Make sure that you're typing this into your calculator appropriately. I use parentheses very liberally, but for me personally, I would actually, before I even type this in, I would just set this off to the side as 180. Because 15 times 12 is 180. Yes? Yes, it is. Okay, cool. I thought I had lost my mind. And so then I would end up with whatever that number is, 2,000 divided by that. I should end up with $702.01. Okay. All right, so that's everything you need for Unit 1. Good luck out there.